Good morning, and thank you for joining this webinar on microswitches and the concept of fiber to the office. My name is Feiko de Boer. I'm the sales manager at Microsens, responsible for the Nordic countries, UK and the Netherlands. And joining me today is our technical consultant, Dirk Herpich, who's been with the company for over 25 years. First of all, a few words to our company, Microsens. Microsens isn't a typical German name, but we are a German manufacturer located in Hamm, close to the Dutch border and close to the city of Dortmund in the western part of Germany. We were founded in 1993 by 3 students, and they developed small sensors for weather stations, and that's where the name comes from. So micro from mini and sense from sensors. To be able to transmit the data from the weather stations over longer distances, the students, they developed media converters from copper to fiber. And that's really where the success story of Microsens starts. We still produce media converters, but nowadays we focus more and more on active equipment for fiber networking. As you can see here, we have our own development team here in this building, and our sales team is located here as well. And we have our own production site with our own SMD line, and everything is made in Germany. Today we'll focus on the enterprise network part of our portfolio, but I just want to show you that we do have some other business fields as well, such as industrial solutions, communication solutions for industrial environments, optical transport solutions for wide area networking, and since a few years also some smart building solutions, for example, PoE lighting or DC lighting. At an early stage, Microsens has seen the many advantages of fiber compared to copper. I'll just name a few. So there's no interference, you have a higher bandwidth with fiber cables, you can reach longer distances, and it's almost impossible to tap into, and you of course lower your carbon footprint as well. Microsens has found a solution to use all of these advantages of fiber indoors. And the key to set up a solution like this indoors is this little switch. We call it a micro switch, and it's a fully manageable full gigabit Ethernet switch with all standard layer 2 features and security options, power over Ethernet plus and 30 watts PoE per port. This switch can be installed in cable ducts, which is more or less the standard, but also in floor boxes. As you can see here, you can add or install a power supply here on the top of the tank, but also underneath in the bottom of the tank. Another option is to mount it into the desk directly and integrate it into your workplace. And the question we want to answer today is, how does this concept work and what are the advantages of fiber to the office compared to standard solutions? So let's start with a short description before we go and dig deeper later on. So FTTO is a decentral cabling concept. It makes optimal use of the advantages of fiber and copper cabling. Standard twisted pair cables are used to connect end devices, but other than that, we only use fiber throughout the complete building. And the advantages are, of course, the elimination of floor distribution rooms or technical rooms on floor level. You protect your investment due to the long life cycles of the cables. You decrease the cabling volume and increase the bandwidth. And this, of course, all leads to lower investments and operational costs. Let's have a look at a typical building with a structured cabling network. I think it's easy to understand if you see the direct comparison between fiber to the office and structured cabling solution to get a better understanding of our solution. So this is a standard structured cabling network, which you're probably all aware of. So you have a central building distributor in the cellar, and with fiber you go up to the other floors, and on the floor you have a floor distribution unit with active equipment. Here you need air conditioning and UPS and other power consuming equipment as well. And from this floor distribution unit you use copper cables through the trunking to get to the end users. And some of the downturns you are probably aware of when you use copper cables is the strength length limitation of 90 meters. As I said, you need a floor distribution room at every floor. And this leads to additional energy consumption for, like I said, air conditioning, UPSs, and so on. For each end device, you need one central port. So you need one central port for an IP telephone, for a laptop, for a camera, or whatever you would like to install there. You need a huge bundles of cables and space to install them as well. And if you would like to increase the bandwidth or restructure the office, you need to replace all of the cabling on floor level. This is what a typical FTTO structure looks like. So you have fiber up to the floor, just as we've seen before. But the big difference is that we use fiber on floor level as well. And for the last meter, a copper cable, patch cable is used to enable PoE or PoE Plus using energy efficient Ethernet. And with this concept, you'll have no length limitation on the cabling. You have no floor distribution is required, so you have more room on the floor as well. And you don't have this energy consuming active equipment on floor level. You have 4 end devices which can share one central switch port, and you reduce the cabling volume with this approach with up to 75%. At this point, I would like to stress that FTTO isn't a PON solution. We'll have a look at the differences with a PON solution and fiber to the office later on in this presentation, but I just would like to stress that FTTO is 100% IP and Ethernet based, with all security features implemented and a much higher bandwidth. But like I said, we will come back to that later on in the presentation. First of all, I would like to show you how much cabling you could actually save. So I've stated here it's 75%, but you could save even more on the cabling. Let's have a look at an example where a simplex fiber cable, which is a standard fiber cable used in FTTH, so fiber to the home solutions, is used. A cable like this, so a simplex cable, is most of the times cheaper than a copper cable nowadays. And in combination with a so-called breakout cable or loose tube, you can even save more than 75% of your cabling. A breakout cable is a cable with several wires in it, which can be terminated or spliced wherever you need it within seconds. And in this case, we're talking about one cable for a complete floor. And with this cable with 22 wires, the size of the cable is smaller than one finger. So it's really, really small. And in this real example, only one cable, like I said, is used for a complete floor. Starting at the technical room, you can connect 11 micro switches, and you can even group a few of these switches and use some patch cables if you want to share the bandwidth with it. So you need even less cabling. For a floor like this with copper, you'd either have to make holes in the walls to reach these working places, for example. And this is of course very time consuming, and you'll also have some issues with fire protection. Or instead of 90 meters of cabling to reach all micro switches, you will need 1 or 4 cables to use this workplace, 4 cables to use this one, and so on. So 4 times 90 meters, 4 times 80 meters, again 4 times 80 meters, and so on. So instead of one 90-meter cable, you need approximately 2,500 meters just on cabling for one floor. So the savings on cabling is huge, 90 meters instead of 2,500 meters on copper cabling. And this technical room can be used for the 3rd and the 4th floor as well. And for a 4-story building, like this example here, you'd only need 4 times 90 meters of fiber cables instead of 10 kilometers of copper cables. So as you can see, you can even save more than 95% just on the cabling. And reducing the amount of copper cabling isn't just a financial plus. I'll explain later on in the presentations which other advantages this has. For now, I just want to stress that FTTO isn't just about comparing the cost on active equipment. Much more than this, you should also take a look at the two other parts of a network, so the central switching and the cabling. I know most planners and tenders separate these parts of the network, but we advocate to look at the complete solution. And if you do this, it's obvious that FTTO is cheaper and more advanced solution than structured cabling networking. In the last few years, Wexøe and Microsens and some installers who are present at this presentation, Ecological and Fiberman, installed and planned a few FTTO installations using blown fiber. And Dirk, if you could give a short explanation on this technique.
Yes, at first also hello from my side. My name is Dirk. Falco has introduced me already. Yeah, I'm working as technical consultant at Microsens, so I'm responsible for all kind of technical questions. And the blown fiber is also a very interesting solution, alternative for doing the cabling side in the building. And the concept is here that you install some tubes inside of the building, at first that are empty tubes, and then you just blow in the fiber cores. And this is a very flexible system because you can just blow in the fiber in the locations as required. You may add some fibers in future. And also in case, for example, that maybe some fibers are broken, it's very easy to replace individual fibers. So here we have a very intelligent and clever system and also very flexible system. And on the central side, it's also very good fiber management. And also if you compare this to a classical copper installation, also the size you need here is only a small fraction of what you need with copper cables, because you have just simply much less cables than in a structured cabling based on copper. Okay, thanks, and I will hand over back to Falco. Yeah, I see the next one is fiber to the office. There's this PON solution, so that's also some slides. I will have a few words about it. On this slide, you can see again the comparison between the three different concepts. On the left side, that's the classical copper cabling, so fiber only in the backbone or floor level, and then in the access level to the end devices, everything is done with copper. In the middle, we have the FTTO network, so that means fiber everywhere in the building, right to the office, to the workplaces, and then the workplace we install the small micro switches, and then the end devices are connected with standard copper patch cables. And now on the right side, this is a passive optical LAN. And passive optical LAN is also based on a fiber cabling infrastructure, but this is initially coming more from the fiber to the home market. So in our opinion, it's more suitable for consumer applications and not so much to enterprise customers. And in this concept, you use also fiber optic cabling, also based on single mode, but then you have some optical splicing or splicers. So you split up the signal maybe in 16 or 32 further fibers. That means the bandwidth or the cable has to be shared between all participants. And here typically it's factor 32. There are also other scales available. But this results also that the effective bandwidth per user or per port is lower compared to an FTTO switch. The length, I think it's in both solutions, it's not so critical in indoor environments. So you can also do 20 kilometer or even more, but for buildings, typically this is more than sufficient. A benefit of FTTO is also that it's an active point-to-point technology. So we have always a point-to-point link and fiber link, and that makes it also more flexible to use the same infrastructure also for other protocols or other services. So if you want to add an analog service maybe which uses fiber, you can easily do it just by reserve one individual fiber for this. Or you say, I need now one for links with fiber channel for storage equipment, and you can easily just use a separate fiber for this. So here you are more flexible with a FTTO solution. Also, a big advantage of FTTO compared to the PON solution is redundancy. With a PON solution, typically you don't have redundancy. With the fiber to the office, you can use redundancy with spanning tree, rapid spanning tree. You can do meshed networks. You can also do ring networks, so that in a case of a fiber failure, normally there's no effect on for the end users. Compared to this, if the PON cable is failing, so up maybe all 32 units or end devices are affected by this. Yeah, another important argument also for FTTOs, in our opinion, is the security. If you look, for example, at port access control, so securing the access to the network, there our FTTO switches are having multiple security features like MAC authentication, 802.1x, radius authentication, and that are features which are not available in the PON devices because they are normally used in the home environment and not so much in enterprise environments. And also mentioned by Falco, the FTTO is using Ethernet protocol in all levels on the fiber and also on the copper ports. So you're not changing the protocol, which makes the administration much easier. With the PON solution, we are changing on the fiber side to a different WAN protocol, which makes also the administration more complex and is also, yeah, one critical point maybe in stability. And yeah, fiber to the office, as it's purely Ethernet, we are also compatible to switches of other vendors. So if somebody wants to use maybe a HP or Extreme or Dell switch in the central side, that's no problem. They're all IEEE standards behind that. It's always compatible. But for the PON solutions, normally the vendor of the PON equipment recommend not to mix different vendors because there are still some compatibility issues. Maybe not all features are supported correct. Yeah, so this should give you rough comparison to PON, because PON is also using fiber optic in the building, in the local area network, and this is also now moving into a market. So, but it's a bit different to our fiber to the office concept. Yeah, thanks, Falco.
Well, thank you, Dirk. Yes, sustainability is really a buzzword these days, and architects and building owners focus more and more on the sustainability of their buildings. But why not build a sustainable network? I don't think a lot of building owners think about that at all. And with FTTO fiber to the office, we offer a sustainable network which combines the advantages of copper and fiber. You eliminate hundreds of kilometers of copper cables, you reduce the amount of power consuming server rooms, and at the same time you increase your bandwidth per user. We've already had a look at some ecological advantages of using fiber to the office instead of copper. So with fiber to the office you have less server rooms with power consuming hardware and air conditioning and UPSs. The lifetime of the cabling is also much longer than that of the copper cables. But let's have a look at some other ecological advantages of fiber compared to copper as well. Fiber has a much lower environmental footprint during the production and also the transportation of the cables. Well, as you know, copper cables are made out of copper, which come from polluting copper mines, and fiber is made out of sand, basically, which is a widely available all around the world. And the difference in the environmental impact of gaining the resources and the production and jacketing of the cabling is really immense. When we have a look at our building example we had earlier with 4 floors and 22 workplaces per floor, you'd have an environmental footprint of less than 400 grams for the complete building when you use fiber. When you use copper, remember I told you 10 kilometers of cabling you need roughly, copper cables. In that case, you'd have an environmental footprint of 164,000 kilos. I'm just going to repeat that. So with fiber, you'd have 400 grams of environmental footprint, and with copper, you'd have a footprint of 164,000 kilos just at the production of the cabling. So I believe that's reason enough to state that FTTO is really the green solution. We'll forward this presentation to Wexøe, who will forward it to you if you'd like. And on this sheet, I've summarized a few other advantages of using fiber instead of copper. I won't spend too much time at this, but you can have a look at it later. And the bandwidth of the fiber cables is almost unlimited, especially if you compare it to copper. With copper, you have a 10 gigabit maximum at the moment. And don't think this will be any higher in future. So as you look at the development of copper cables in the last 20 years, it started with Cat3, Cat4, Cat5, Cat6, and Cat6A is probably more or less the standard nowadays. And if you install fiber cables, you don't have to replace them if you want to increase your bandwidth, making it really future-proof. If you want to do the same with the copper cables, you'll have to completely change your copper cables in your office. As you can see on this slide, our microswitches have been around for quite some time, and while the typical life cycle of office environment equipment is around 10 years, so not only for microswitches but also for other switch manufacturers. But we know our switches really surpassed this 10 years, as we know we still have some customers who have a generation 3 fast Ethernet switch installed in their cable ducts, and they've been running since 2003. And we still support these switches, but of course we recommend to use the newest generation with Gigabit Ethernet, PoE Plus, and so on. And if this customer would like to upgrade his network, he can simply use this new microswitch and just click it in. So it's really plug and play, and you're ready to go. And as we use the same form factor and the same cabling. And as I said, if you want to change the bandwidth with your copper cables, you have to replace the complete infrastructure for that. And when we talk about increasing the bandwidth in the coming weeks and in the next quarter, Microsens will introduce a unique new switch with 10 gigabit. And Dirk, if you could share some information on this switch.
Yes, so that's the next generation. We call it generation 7. And with this switch, we will have the smallest FTTO switch available on the market worldwide. And clear target was here to have the same form factor. So it's based on this 45mm design, and the size is 2 × 45, so that it fits exactly into the same mounting adapters and boxes and closures as the previous 1 gig and also the 100 gig switches are fitting to. And benefit here is that it's very easy and simple for the end user just to upgrade from existing installations to the new one. So just by click installation, remove the old one and install a new 10 gig FTTO switch. The release is planned for Q2 this year, so very soon. The development is almost finished here. And the switch will have in total 7 Ethernet ports. 2 of them are designed as SFP Plus slot. So that are the 2 fiber ports. You plug in SFP Plus, which can be any type, multi-mode, single mode, duplex, simplex, any type of SFP Plus. They can also operate with 1 gig speed. Then we have 4 access ports for the end devices. supplying PoE up to 30 watts per port. And then on the opposite side of the fiber ports, there's one additional multi-gig port, which is supporting 2.5 and 5 gig, and also PoE 60 watts per port. And this port is mainly designed also to use high performance wireless access points, because today these access points are often providing more than 1 gigabit speed on the wireless side. That means they also must have a cable uplink with more than 1 gigabit speed. And this is done then with 2.5 and 5 gig. And this is also, I think, the main driving application at the moment for this 10 gig FTTO switch.
Okay, so thank you, Dirk. I've been talking a lot about the cost effectiveness of our solution as well. But as you know, I'm a salesman, so I'm sure it's hard to believe everything I tell you. So that's why we've asked an independent institute to compare the costs of fiber to the office with a structured cabling network. This institution is called the WIC Institute, and it's funded by the German government. And they did a complete comparison of the two solutions. So this study compares the investment cost of both cabling concepts and the operational cost over a time of 10 years. Compares also economical topics of both concepts. It covers all relevant cost factors. And yeah, we prove, or the proof is done via the results of real projects. And WIC compared two cases, a building with 220 workplaces and 5 floors, and a large office building with 1,000 workplaces. The results shows that regardless of the size of the building, or it being a renovation of the building or a new building, FTTO is much cheaper. We'll share this study with Wexøe, so you can compare the calculations for yourselves as well. And to be honest, I'm actually pretty sure you can save much more than 30% on your network, as we of course have improved our solution over the last years. This study is from 2012, and fiber cables are getting cheaper and cheaper as well. So at least 30%, most of the times more than 30% you can save. And the cost reduction on your yearly energy bill for a building with 220 workplaces compared to a structured cabling network and you use FTTO is at least 40%. And the bigger the building is, the higher the saving on your energy bill as well. FTTO is implemented worldwide at many different locations. Our biggest references or reference with the most installed microswitches is the Dubai airport, and we've installed there 13,000 microswitches. We've also installed our solution at other airports like the Dortmund airport or the Tucumán airport in Panama. In Dubai, they only use 2 technical rooms for a complete hall instead of 150 technical rooms, which were planned before. As you can see here, the number of access switches they saved here is 2,340 access switches. So that's a huge number and a big saving for them. Another typical customer of us is banks, due to the advanced security features we have implemented in our FTTO switches as well. We've developed a microswitch with all medical certifications, so this can be used in operating theaters. And one of our biggest references is the biggest hospital in Germany. It's called the Charité in Berlin, but also other smaller hospitals in other countries like Poland, France, and the Netherlands use our microswitches in the operating theater and throughout the hospital as well. Another typical vertical market is universities, and with the Viborg Gymnasium and the Architect School in Aarhus in Denmark, we have 2 interesting references which can be visited. after the corona pandemic allows us to travel there, and I'm sure Wexøe would like to invite you there as well in a few months' time, so you can see for yourself how an FTTO solution looks like. Last but not least, I would like to show you some office buildings. We have FTTO implemented in some new kind of open plan offices where a lot of space is needed, but also in older buildings with a lot of restrictions, and where it's not a lot of space, and fiber is of course much easier to deploy in a building like this with all the restrictions than copper cabling. So for now, I would like to thank you for taking a look into FTTO, to fiber to the office. And next week, we want to invite you for the next seminar. We'll take a deeper look on the technical details of the microswitch, the management options, sorry, for the microswitch, network topologies, and also the future of fiber networking. So yeah, I hope you'll join us next week, Tuesday, the 23rd of March at 9:30 in the morning. Just send a short email to Yes or someone else at Wexøe, and we're looking forward to having you there next week. Thank you for your time.
Yeah, thank you very much also from my side, and hope to see you next week then.